welcome everyone. So excited to see so many of you today. Thank you for all your questions. We had some time before the actual event to discuss some of these questions. Thank you for all the questions and inquiries that we received over the last couple of days. I'm sure we'll get a chance to discuss most of them. Before I introduce today the most stellar lineup, let me just quickly go through some housekeeping items. So, yeah. The first one is, although your computer is muted, you can ask questions in a Q&A tab. Please do ask questions. We'll make a break every once in a while to answer all those questions. The webinar is being recorded, so for all of you who were not able to join, yes, you will be able to watch this as a recording. And if you have any issues with Zoom today, please reach out to Zach and me. So let me introduce our panelists for today. So let's start with ladies first. Chip Huyen from Claypot AI. Welcome, Chip. It's great to have Claypot for the second time. Abhay Bothra from Fennel AI, Rohit Agrawal from Tecton, and Yingjun from RisingWave Labs. Welcome everyone, and thank you for joining us today. So today's topic has gained really a lot of attention, and we received so many questions. And one of the reasons is perhaps that we live today in a real-time world. Like each of us is producing so many, such a huge amounts of data every milliseconds, and businesses are struggling to process and collect those data as they want to have insights at light speed. At the same time, machine learning is becoming more and more a household word. With it gaining popularity, and it's also becoming more prevalent and across different industries. So what is happening with stream processing and machine learning meet? Or as Chip has put it, almost 2 years ago in an article, when machine learning goes real time. So perhaps we can start today's panel by trying to unpack what it means when machine learning goes real time. So the first question for the participants today can be how real-time machine learning is different from batch machine learning, and what are these different types of real-time machine learning? Who want to start?
I think she'll have some.
I can take a stab at that. So at least how I think about it, there's maybe 4 aspects to real-time machine learning. And let me start. So if you take a classic movie recommendation example, you can think of it as all the way from, is your retrieval real time? Like in the real time, are you considering what items, for example, to rank or what movies to rank for a user? Secondly, are your features real time? Are you considering their real time activity when computing their feature values? Is your model serving real time? And then lastly, is your model training online as well? And so these are at least the 4 pillars in my mind when it comes to real-time machine learning.
Yeah, I think I agree. So usually analogy I usually use is think about you ordering pizza, right? So so one way is you want the pizza to be really fresh. Then you just make everything at order. You make the dough, you make the sauce, and then you bake the pizza, and then you get it back. So the downside of that is that the latency is high. Right, so you think of on the dough, on the sauces, the other features you need for the model, and the baking of the pizza is generating predictions. So there are other ways you can go to reduce the high latency. It's one that you can either pre-make on the ingredient, on the dough and the sauce in advance, and as a time of order, you just get the pre-made dough and sauce and make the pizza. So in this case, so it means that we have the features that pre-computed, and the predictions are generated in real time. Or another extreme case is that you just like pre-made the pizza in advance, right? And then at the time of order, you just fetch the pizza. So in this case, the latency is the lowest, but at the same time, the pizza is much stale. And also another big cost of this is that like you do not know how many pizzas we're gonna order today. So if you pre-make a lot of them on the same day, or like beforehand, like you might waste a lot of pizza. Like nobody like wasted pizza, right? So so that is a downside. So I think that there are a lot of research I've seen pretty consistent in other website. That's like only a small percentage of like users actually log in or like do activities on the site. For example, Grubhub, only 2% of the users make daily orders. So like if they generated for prediction for every users every day, then 98% of the predictions are going to be wasted. So yeah, that's what I think about as real-time machine learning.
Yeah, and then I can just add one more thing, which is like the transition from like a user's journey. So we see a lot of customers start with like what we call the batch in the sense that their data sources are batch and their inferences are also batch. And then they move to a world where their data sources are still batch, but they're starting to make real-time inferences. So the serving gets it like real time. And then they get to the stage, which is like almost like crossing the chasm, which is your data sources are real time and the inference is like real time. And so that's, how we see the progression of the market, generally speaking. And then the third category unlocks, I would say, like net new use cases that were not even possible with like either batch or batch online. For example, like very real-time fraud or risk detection, etc., is completely net new use cases get unlocked once you reach that stage.
Yeah, so I feel like, sorry, can I add something else?
Please go ahead.
I don't want you to hop on the top. So I think it's like, I do think of batch as more of a hack to like overcome the latency issues. And also it's a legacy from data system because a lot of companies already have Spark running, Hadoop running for many, many years. So when they started to move toward machine learning, then they just like inherit a batch system. But actually, if you come from a more research background, right? When you build a model, you test it. It's not batch, like you send a request and you get back a response. So a lot of that is done in real time. And only when you move to production that you move to batch because it's just what our existing data system can handle. So one thing I actually really like about all the generative AI stuff is that people realize, oh wow, people actually love real time, right? Like it's this like model of like sending requests and get back a response. You just have to compute a lot of things in real time.
So I'm actually probably the only person that do not really work on machine learning, right? So I'm a database guy, and but my question, so though I'm a panelist, right? So I want to raise a question that is, what's real time? Like real time means second level or latency, like second level or minute level or hours, right? What's real time? What does real time mean?
I mean, I can give you input. So I think we think of it as like two signals. One is near real time and one is real time. Near real time is typically what we consider like streaming. So Kafka Kinesis. Typically, if you can have features available for serving within 1 second, that's like near real time. And then real time is when, let's say, the inputs are available only at inference time. So for example, let's say you want to compute like geographical coordinates, or you want to compute like the credit score of the person at that moment in time. That's like real time. That happens in like less than 50 milliseconds or something. For the most market, like the streaming use cases are like under a second. And then once you go to like complete real time, like request level, that's like less than 50 milliseconds.
Yeah, so actually that matches my understanding. Well, it seems that it's more like for now I know that's where a lot of people are still also working on the online training, right, and all real-time training. So it seems that people have strong requirements on inference side, right, and prediction, basically prediction serving, right, model serving, and seems that they don't really want to have, let's say, if I want working on a recommender system, I probably don't really want to have a latency set to hours or probably even for minutes, right? So they just want to have the latency as low as probably just a seconds or probably just a milliseconds, right?
So I think like for me, like I agree with this divisions of like real time, near real time, batch. But I want to point out that like this is not like arbitrary division, right? It's not somebody come up and like, oh, we come decide, okay, if it's less than a minute, then it's real time is like a minute or so, so it's near real time. It's not arbitrary. So I do think these boundaries are created by using the limitation of technology, right? So we think about this, for example, like I do think it's like the large part of the engineering is moving data like from one place to another, and there are different ways you can move data. And these different ways are what cause the latency or the freshness issues. For example, like one way to analyze passing data is just like you just pass it through databases, right? Like you just put everything into Snowflake or everything to S3 and somebody access it. And that is when like the how to put data in Snowflake and how to read from the Snowflake costs latency, freshness. So it could cost maybe like 10 minutes or something. So that's why I say, okay, so maybe like above 10 minutes or 15 minutes and it's batch, right? Another way of passing data is just like when you just send data instantly through requests, like HTTP requests or other like gRPC. So it's instantaneous, right? So like it's an order of like maybe like milliseconds stuff. So that's when they have like real time, like very real time. But the issues of that is like there are a lot of people discussing or even like passing data through a database, online databases like Postgres. So there are a lot of people discussing whether it is a pattern or anti-pattern of data passing. And there are some people like pros and cons. I think there's a huge discussion at some point about like whether Postgres can be used as a message queue. And there's somebody like, no, absolutely, it's trash. You shouldn't do it. And there are people like, oh, we have been like architecting this very massive scale system using Postgres. So it really depends on like, where you stand. But I feel like that, of course, there are a lot of issues with that as well, because like you just really do not want, like for the request problem, for the request pattern, it's not very scalable, like because like you have this like the host has to wait, like the server has to wait for the client, the server has to be up to respond. If the server is not up, then it's just like you can't process it, and the client keeps sending a lot of messages, and it can cause a lot of issues. And for the Postgres case as a message queue, I don't think it's as reasonable to have a lot of like system can just write to the same database and change like database like in real time. Like I don't think it's a good pattern. But anyway, so like that's when you have the real time stuff, but then it has a lot of issues, and then we'll move to like, okay, what if it passed by using some like streaming transport, right? Like something like Kafka or nowadays like Red Panda stuff. So now in this case, it costs this like it takes certain time for the data event to be ingested into like Kafka. So it can be cost like seconds. So that's where the near real time come from. Like, okay, because now you can make it scalable and it's pretty fast, but not quite as fast as real time. So now we have this like boundary of like several like seconds, and that is what is near real time is.
Thanks, Chip. Anyone wants to add something?
Yeah, no, I think I agree with what Rohit and Chip said, which is that very, very real-time use cases, like especially like fraud detection and fraud detection have second level of like requirements in terms of end-to-end processing of signals. So an event happening to that being reflected in a feature value. For example, we work with customers who want it to be within a second. And like recommendation system use cases generally tend to be slightly less stringent about that. But even they are like, if you can, the earlier you can accommodate, the better. So you can take TikTok as an example, where they're taking very real-time activity of users on the app as an input to what to recommend next. So the earlier the better for them.
Thanks, Abhay. So one of the questions that we have been like receiving is like, so oftentimes people are saying like building real-time ML pipelines is really like difficult, requires skills both on the streaming and ML side. So what would be the key challenges, both from a technical and from a business perspective?
I think I can go first. Well, again, I'm the only database guy, and we built a stream processing system, and we do not really touch too much about the machine learning. But we know that people use our system to do machine learning, and what I can see here that there are actually two parts of challenges, or two separate pieces. One piece is that okay, what's the underlying streaming infra, and what's the machine learning tools. So for the streaming infra, it's more like, okay, so look, I mean, if you want to just store data, probably you can use Kafka, right? So you can probably use Kinesis, you can use some other messaging queues, right? Red Panda, right? Well, I mean, if you want to use to do stream processing, to do stream computation, then basically there are a few options that, like, for us, well, it's RisingWave. and there are also Spark Streaming, and there's also Flink and probably some other systems. So that's about what data infra, and the people care a lot about the cost, how to reduce the cost, and whether they can serve queries right way, and also about what the exactly ones for sure right way, and yeah, there are lots of data infra challenges. But what I observe is that it's not enough to build a solid machine learning platform, because well, I mean, people actually wants to use all kinds of the machine learning libraries, probably in Python, right? And they want to collaborate. They want to integrate with their Python libraries, and they probably really want to build some nice machine learning tools and can integrate with their machine learning infra like TensorFlow, like their PyTorch or some other systems, right? And they also have their what is called a model serving system, right? Probably they have separate model serving system. So from my perspective, I think well, for stream processing system, it's kind of only the one of the key parts of the machine learning, of a bigger machine learning, real-time machine learning platform. But with if you want to build inside a company, if you want to build a real a comprehensive machine learning infra, then probably you want to borrow different pieces and try to hook them together, right? And to glue them together, right? And yeah, that's what I observed.
I can add like some more things. So I can go on about like a lot of challenges, but I'll focus on like two. One is that for like machine learning, you typically have two workflows. One is your training workflows and one is your inference workflows. And so typically training data is coming from like batch sources, or can be, and the inference is coming from a combination of batch and stream. And so there are two problems here. One is that how can data scientists write the same transformation pipeline that can be executed in both batch and in like streams or like real-time manner without having to build like two separate feature pipelines. And then the second thing, which is that how do you avoid like training and inference skew? So you want to basically train on the same data that you are like inferencing on. And how do you avoid like skew if you have like different pipelines? So those are like things like that like typically first come to mind. So if you're moving from like batch to real time, you will have generally a pipeline that works for batch. And then you're like, how do I make that work for stream? And we'll see a lot of cases, people who have a completely different pipeline for like the real time stuff. And then they end up in this like split brain world, basically.
Right, and what Rohit is saying is very much like an artifact of the so-called Lambda architecture that was popular 10 years ago, that got popularized, I think, by Twitter and LinkedIn, and where basically teams would be writing the same feature pipelines for batch and real-time use cases. But I think we are now slowly moving into a world where you can have what's now called the Kappa architecture, where most of your computation is entirely written as a stream processing workflow. And you are able to use that same workflow for doing like efficient backfills as well as computing features online. And so that really reduces the friction for people to author these features. And maybe one more thing I want to add is that one of the challenges that really comes or that makes online offline skew very real is, for example, having efficient point-in-time correct joins and doing that correctly when you're generating your training data, and when you're doing online lookups for real-time serving, and doing in such a way that you don't have feature values that are different for training and inference is very important. And that's where, for example, I think we start to separate like general purpose streaming systems from like purpose-built systems for machine learning, where you're able to get those like point-in-time correct feature values for model training.
Yeah, so I definitely agree with what everyone said about like the importance of like train predict inconsistency, and also about the backfilling. I think it's really hard. I think I just add a couple of things from a data scientist perspective. So I do think like one of the biggest things I've seen data scientists when they encounter like when it comes to streaming is that like batch job is a one-off job, right? You run the job, you're done. You run it again, you get the same result. But a streaming job is like ongoing, so it's really hard. So like you have to kind of set up a service and like keep like data keep on coming in, and when we run it again, you get a different result. So like going from a one-off job to a long-running job is like pretty hard to set up locally and have like experimentation running, and you can like make sure it works. And the second thing is that I actually, this might be a plug for RisingWave, because I do think I'm very excited about RisingWave for this aspect. Is I do think a lot of existing ecosystem in streaming is in like based on JVM, right? Java. I think Java is a dying ecosystem. I'm sorry. Like I know that Java is incredible. There's a lot of incredible there, but if you look at like Stack Overflow like research, right, it's just like the percentage of people using Java each year is just like consistently going down since like 2016 or 2017. And nobody likes Java. I think like it causes most, okay, maybe there are people who like Java. I'm sorry. But I do think just like there's a lot of room for having like for moving the streaming ecosystem away from Java. And I think the data scientists just do not like working with Java. So we see a lot of people like, okay, I love Flink is a great computation engine, but then I just need that Python API, you know, and some people want to settle for something like, I don't know, like Apache Beam, which of course Apache Beam is another like a lot of issue with the API as well. So I see like the new generation of my streaming tools built on top of Rust with like Python API. I think it's very exciting.
Yeah. So actually, yes, thanks, bro. I'm definitely a Rust fan, right? So I built my system on top of Rust, and but I do not really hate Java. Well, I know that actually a lot of people are still using Java, but well, that's fine. But well, I mean, one question from my perspective is that okay. So do you think that okay, people in the future? I mean, they were I mean, they will have different pieces, different systems, and then try to put them together. Or you think that okay, people really want to, I mean, build an all-in-one system from scratch? Because I know that's where people probably use some existing systems like Snowflake or like Databricks, right? And I know that's where for Tecton, I think well the underlying system is probably you can support both for Snowflake and Databricks, right? But for Fennel AI, I think well they build everything from scratch. Well, if I got it correct, right? Well, so my question is that well, so why people are building these things well in different ways? Yeah, I'm curious.
I can answer why.
Because from my perspective, I'm providing a data infra. Yeah, that's go ahead.
It's a very good question. It's not just because of love for Rust, which many of us have. But really, at least for Fennel, it boils down to giving that experience that Chip was talking about. We want to have it. The data scientists really want to have a Python-based interface. They don't want to like fiddle with Flink configurations and stuff, and operate and manage Flink clusters. And or what we see, for example, is a lot of like proverbial throwing over the wall of features where data scientists will author their features in a notebook, then throw that over the wall to a data engineer who's now well versed with Flink, and then can translate that to like an more of a Flink pipeline. And so if you have to give that Python experience, Rust has a great Python interop story, and it allows at least Fennel AI, for example, to offer an experience which is very hard to offer with if we were to build that system in JVM, right? And so that's why we at least chose to build our own like stream processing engine from scratch. And Yingjun and I discussed like very early when Fennel was just starting on this journey on what his learnings were building RisingWave on Rust, for example.
That was probably 1 year or 2 years.
Like a year ago, yeah.
2 years.
Yeah.
Okay, that's right. Yeah.
Yeah, I can add just like few more things on top of that. So one is that yes, we integrate with Databricks and Snowflake, but we also have our native streaming engine where we also integrate with like other platforms like Dataproc, etc. So we integrate with a whole bunch of stuff, and then we have our own layers on top. The one thing I will add is that I've noticed this with working with a lot of customers as well. When people are crossing the chasm from like batch to streaming, there are just so many new concepts that they need to like suddenly learn about that they never had to think about. And for example, like watermarks, checkpointing, snapshots, out of order data, late arriving data. And there are just so many new concepts that they suddenly need to think about. And these are not really related to the features that they're writing, but just until they really deeply think about it, their pipelines will never be production ready, right? And so one thing which we try and do is that how do we create an abstraction that is higher up from like the streaming platforms where the users don't necessarily need to think about all of these things, especially in the context of machine learning, for example. So for example, if you're a data scientist trying to, and you have, let's say, a Kafka stream of transactions coming in, like how can I make the product simpler for you to get started with to build features so that you don't have to think about like trigger interval, micro batch processing time, snapshots. Like there are so many concepts that you don't need to think about right now when you get started with, and make it very simple for you to get to production quickly and get value very quickly. So that's, I think, one more addition where like the tools right now don't necessarily have the right level of abstraction that we actually need to build very powerful systems on top of.
So I think like from a consumer perspective, I think just want to add on about the question about like whether you want to everything into one systems or do you want to do different pieces separately. I do think that like as a consumer it can sometimes be confusing because sometimes they're like, okay, I want everything in one place, right? I want everything just like working together well. For example, if I use Chrome, I also want to use Android, I want to Google Drive, I want everything into like it makes things a lot easier. But at the same time, people just hate vendor login, right? Like, okay, so when I talk to companies, they are two school of company. Like one is like, okay, I want to put everything on Databricks. I want to put everything on GCP. Or another school of companies is like, okay, I want to avoid vendor login as much as possible. So they spread things out like multi-cloud strategy or whatsoever. So I think that it's so it's not just a machine learning platform. I think that people need to decide for themselves like what's the works best for them. But also I also see the similar thing in the data systems. I do think just like data system is pretty fragmented today. So like we have like a lot of like data warehouse, we have like databases, we have like streaming transport, like Kafka and stuff. So I do think just like it can be pretty hard for data users to get familiar to own this different part of the system and can like, access data easily. So I do think there's a big challenge of like machine learning workflow for data scientists to be able to get all the data that they need to build their model. So I do think just like recently, I do think just like a keyword that I think is going to be the buzzword for 2023 or 2024. I know that like modern data stack was a keyword from like a year or 2 years ago, right? And the next keyword is going to be like interoperability. Am I saying it right? I'm not a native speaker, so it's like being able to like work with multiple systems. So I do think that I see a lot of companies are doing is like having the like compiler in the middle that can connect to all the different data sources and data system, so that like user can write the code once and they can execute in like in Snowflake SQL, and execute in Spark SQL, and can execute in Flink SQL, even RisingWave, and in any system underneath the hood. So what it brings is that if you as a users you want to decide to switch the vendor, like if you want to switch from Snowflake to Databricks, then you don't need to rewrite their code. You just need to change the configurations. Or if you want to like use the same feature configurations for streaming instead of batch, you don't need to rewrite from Spark SQL to Flink SQL. You can just keep the same code. So I do think that's like pretty powerful. And also as a practice approach that like Claypot was used as well.
So in Claypot, it seems that's okay. I can use the same set of code, right? For both Spark so for both batch and streaming, right?
Yeah. So it's like,
Yeah.
So
go ahead.
So we pursue the compiler approach, right? So you write the code in Python, and it says it's like, okay, so like think about like, oh, say you have a lot of transaction data like coming in, right? So it might first come in through like Kafka, and then it'll write Snowflake maybe like a little bit later, right? So now you write the code as just like, hey, I want these features computed like very fresh. Oh, like I say, I want this feature computed like as a 10 minutes fresh. It was like, so our compiler will look at it and say, okay, for this, it's very best to compute it off in the batch mode, then it will compile the code into the batch executions. But if you say like, hey, for these configurations, I want it to be like a second fresh, then we say, okay, now you need to compute that, compile that into the streaming mode, and we compile the streaming mode. But users are pretty much agnostic to like how the execution happened. So you just write the code once. So think about like you can think about a compiler for like hardware, right? Like you can write the code once and it can execute on either GPU or like CPU. Like you don't really care about how that happens in the hood.
Yeah. So I think there's one question asking,
Yes.
okay, how will a useful system architecture look like if you guys put a systems represent together? Okay, so system together. I think we'll cover all requirements for online machine learning inference with dynamic features. So I don't know how much overlap there are among Fennel AI and Claypot and Tecton. So anyone want to explain a little bit? Is there any?
So for the whole question, you have it in a QA tab.
Yeah, I'm not sure I understand the question. Yeah.
So I think the question is that so is there a huge overlap among different the systems we are presenting? So I think definitely for me, well, I mean, I'm representing RisingWave, right? So I think there's a huge overlap, huge difference between overlap and I mean, Claypot, Fennel AI, and Tecton, because we are more like data infra and stream processing system and streaming database. But for Tecton, and Fennel AI and Claypot, well, they are more like feature transformation platform, if I understand correctly, and
So
or if I say,
yeah,
or more like, go ahead.
disclaimer. I do not know what Tecton is doing, and also do not know what Fennel is doing. I know that you guys are great teams, right? So I don't think this like is. I also know that from talking to companies, they consider this very different. So yeah, I do not know, like, so.
Yeah, I can
but
definitely say that there is some overlap between what we do and Tecton does. We are both feature engineering platforms, and coming at the same problem with two different perspectives and angles. But there's definitely a bit of overlap there.
Okay, while we are at questions, can we answer the next one? How is the accuracy of a model affected by transitioning from batch to stream processing?
Getting way, way better.
Can you please elaborate on that?
I think it depends on the use cases, right? But I don't think I've ever met a company that's like, I wish our features are more stale. Like, I wish our data. It's just like, I feel like the consistency we have seen is just like the fresher the data, the better the model performance. But of course, like how much of a lift is a question, right? Maybe the lift is like minimal, but some use case and lift can be quite big. So it really depends on the use case.
Yeah, like I can give one example, which is for recommender systems. Typically, you can like do experiments like A/B different experiments and measure like GMV or like gross merchandise value that you sold with like different models. And for like almost all companies, you will see like a very significant lift in like GMV, which is like actual dollars that are being bought on your platform with like different models, essentially.
Okay.
Yeah.
Oh, I think maybe one use case could be fun for everyone to today. Is just like generative AI, right? It's so easy to create bots and like fake chat and spam and stuff. I do think bot detection is a use case that you can really benefit from like real-time detections. Like before it caused like a lot of damage, right? Like I'm using Discord today and I'm just like so frustrated because there's so many bots. It's like, Discord, come on, do something about it. Yeah, I just feel like I think LinkedIn has a case study when they switched from like batch to streaming, and they were able to catch like 30% more bad actors like in real time.
Yeah. So actually back to a previous question about the system, would it cover all the requirements for online inference with dynamic features? I think that's pretty interesting question, because from our experience, we find that for the streaming, different from batch, one of the challenge here is that the upstream system schema can change, and the queries can also change, right? For batch system, it's kind of simple because like the input schema never changes, right? Well, I mean, if you change, if the schema changes, then probably you can just run another query from scratch, right? But for streaming, I think it's quite different in that. I mean, stream processing is like continuous query processing, and if the upstream data changes, then actually, in the worst case, probably you have to recompute, and essentially that's something that a lot of I would say some stream processing system, for example, RisingWave is trying to address. Basically, like, what if the upstream data changes, and how you can guarantee that there's no downtime, there's zero downtime, and we develop a system, we develop a feature called alter MV, alter materials view, to ensure that there's no downtime. But I think in machine learning, I think there's some more. Yeah, right. Well, there are some more stricter requirements for like, because for machine learning, I think the data sets can also change a lot, right? So anyone wants to chime in?
Right. I think in addition to what you're saying, the schema evolution, for example, Yingjun, I think also presents a very interesting challenge, for example, in streaming systems, also applicable obviously to feature platforms, which is the inability to do a lot of query planning, right? Because you don't know what the shape of the data is going to be over time. And secondly, when it applies to machine learning, for example, In addition to like schema evolution, for example, you have to think again, like I think, for example, like low latency serving, for example, becomes very important. I think that's one of the main challenges I can think of, in addition to what you mentioned.
Okay. So any trends, we were getting some questions. I'm also getting some questions through email. So I know you will hate this one, but it's part of this like future trends. So the question is, are most large language model optimized for real-time input? This is obviously something that people want to hear about.
Wait, what's the question again?
So the question is, are most large language model optimized for real-time input? That's what people want to hear, and about future trends and about artificial general intelligence and how it is aligned with real-time machine learning.
So one thing I'm really excited about LLM, actually, so one of the first project I worked with was like Nemo NVIDIA, which is like now generative AI framework, right? So I'm very excited about generative AI. LLMs, I do think just like the pattern that we will use it today is just like really real time, like unlike predictions, there's no batch there at all. I mean, of course, there's batch in training, but not in inference. So I do think it's really incredible to see how people have managed to get LLMs, like really big model, to generate response so fast. Like you can input like really long documents and you can get the first token response instantaneously. I thought it's super awesome. I think a lot of work being done in that space. First of all, like a lot of like model optimizations to make models smaller, faster. Another work is just like on the parallelizations of tokens, like the input token actually process in parallel. So that's why it's just like it's scaled pretty fast with like a lot of very long documents. And whereas the output token are processed sequentially. So that's why you can see the response actually slower than there's a response slower if you have more longer responses, and also a lot more expensive. So I do think it's like that is a lot of work in that space. One thing that I do think is like real-time data is very important for LM is a use case of like RAG. I'm not sure if you're familiar, like retrieval augmented generations is when you connect the LM to like a database and you can fetch the database as a context into the model input so can have it respond faster. So I do think a lot of questions, a lot of use cases that require context, right? So say you have a customer support chatbot and the customer asks like, hey, can I change my order from like the size M to size L? And you have to you need to context like, who is that person? Does they actually make that order? Has the order been shipped? Is the size L still available? You know, like, so all of that context you need to fetch from the database into the context so the chatbot can respond. And all of that needs to happen in real time because users don't want to wait too long for that response. So I do think that's a use case that people are actually working on, and where streaming could be very important for our.
One thing I can add is that like we had some folks like build features on the platform that they were already using for a different model. So let's say a feature like order value or like sum of order value over the last 5 days for a user. And what they did was that they had like prompt templates that were like static prompt templates, but at customer support time or something, they would like inject these like feature values inside that prompt. So they are no longer static prompts now, they are prompt templates, but injected with like real-time features that are be computed in the platform for other models as well. And you just like use those values to build like better prompts for your model inference. Yeah.
Anyone wants to add something?
Well, actually, I'm actually not a big fan of LLM. I mean, I like the technology, but I think I don't like the buzzword because everyone nowadays is talking about LLM, right? Well,
it's
but
not
anyways,
buzzword. It's like calling the internet buzzword.
Yeah, but anyways,
I'm big hype. I'm sorry.
Yeah. Okay. Anyways, yeah, I think for the I think for LLM, the opportunity here for streaming processing is more is that actually it generates a lot of data. I think that's definitely that's something we're looking into. because well, I mean, look, well, think about the I mean, if you post if you write articles, right? Well, I mean, probably will take several days, but nowadays we're just one click, right? So I think well, it means that okay, a lot of data will become fresh data. It's not big. It's not just a static data. So definitely, I think that's an opportunity. And for machine learning, similarly, yeah, people may have the requirement that well, they probably want to have fresher results based on the fresher data, right? That's my observations regarding the LLM. Yeah.
Yeah, I do think, for example, LLMs with all the generative capabilities will present significant opportunities for doing very interesting machine learning work, also around real time. For example, as Chip mentioned, if you have lots of bots and lots of spam accounts and being able to quickly detect them and be able to stop them. For example, if you're LinkedIn and you want to stop fake profiles, you need to act quickly because these bots can very quickly spread through the system. And I think it presents real opportunities for using real-time machine learning.
So what are the main trends that you're seeing in the next 2 to 3, 5 years?
So actually, there's one question. I think it's so how can we bridge the language divide since there are data scientists working in Python and data engineers in Java? The model developed in Python then need to be translated into Java.
That's what we do, right? We are compiler, so people just write the one thing and we compile to whatever computer engine and it will good. So yeah.
Yeah, I can just add that like basically we focus on building the declarative framework where you can define features and in some way you basically apply them. So there's like a CLI command. Once you apply them, it basically takes care of compiling the declarative pipelines into the actual physical code that's run to compute all the features.
Mm-hmm, mm-hmm.
Can you go back to the trends? What do you see next 2, 3 years?
So we do see a lot of use cases for real-time ML, and we think the unification of batch and streaming is something that's going to become more and more like sort of complete in the next, if not 2 years, but next 5 years. And the distinction and the walls will keep falling down. And the other trend that we see is, I think that related to the question that we were just discussing that I think Emily had, which is thinking of like real-time machine learning as more of a collaboration between data science and data engineering, and enabling that through the right abstractions, right libraries, so that you can speak both of their languages on the same platform instead of throwing it over the wall and having to rewrite your features from Python to Java. And creating that abstraction is something that will also, I think, unlock a lot of opportunities, and the velocity, for example, of deploying new features will really go up, and we'll see more and more sophisticated machine learning systems out there as that happens.
Yeah.
Thanks. Who's next?
So yeah, I can be the next. Well, I think from my perspective again, well, I mean, I speak more from the data infra perspective. What I can see here that no matter whether people want to glue all kind of different system together, or they just want to use one single system, right? Either Fennel AI or probably Snowflake or Databricks, right? What I can see here that the people do not really need, I mean, within the next probably 3 or 5 years, people do not really need to learn too much about the technical details, the data infra details. They probably do not really need to know, okay, how to write Java, what's the Databricks SQL look like, right? Or what Snowflake SQL look like, what RisingWave SQL looks like. I think what they will see is just like a unified interface. Probably the data infra can be different. Probably some people are still using Snowflake. Probably some people are still using Databricks. Or probably some people are still using Flink. Or probably some people are still using RisingWave. But what I can see here is that I mean, people will use a single unified interface for both batch and streaming. And they do not really need to learn too much about, okay, what's the difference between stream and batch, right? probably there are some things where like some technical details, well, watermark, probably they need to learn. But I think the learning curve will be much lower, right? Well, much steady, right? Well, they will never know a lot about, okay, what checkpoint is, right? No, people don't need that, right? And people do not really want to know, okay, how I can recover a streaming drop, and how I can alter my streaming pipeline, right? Well, people do not need to care too much about that, and we just provide them a unified interface, and we take care of their data infra. Yeah, that's what I can see.
Waiting for Rohit and Chip.
I think pretty much what Yingjun said. I think the abstractions are getting higher, so you need like less cognitive overhead of like thinking of these concepts. Also, increasingly seems like SQL and Python are becoming like the lingua franca of basically like development, and essentially like it's the job of data infrastructure companies to make sure that Python code is scalably able to execute across like batch, stream, high QPS, low QPS, etc. And so that increasingly seems to be the trend. And then yeah, I mean, we've already seen this, but like just continued growth of like streaming jobs, pipelines, and like more and more features moving to real time. It's like a very mindset shift. Like you will see with customers who move to real time, the native way to start thinking about is like everything is real time, and then the batch is almost like not what they first think about. It's just like completely different mindset.
Thanks.
Yeah, I definitely agree with like higher level abstractions, making things. I do think that generative AI did bring one interesting thing is that like it make it so much easier for people to build ML applications. So before I need to have a lot of like coding skill or have a lot of my ML knowledge, but now like almost everyone can like hit an API and build some applications. So I do think this like the trend is I have to make the API level as easy as possible so that anyone can use that to build application.
Thanks, Chip.
So actually, I have one question. So when people move from batch to streaming, what's their major concern? Do they really care about the learning curve, or they care more about the cost?
I think you shouldn't have to worry about anything at all. I feel like the batch of streaming is a very arbitrary divisions, and as a result of technology limitations. I mean, like, why should it be 10 minutes instead of like 15 minutes or 5 minutes, because things can just get like faster over time. So I don't think we should worry about that at all. So it's yeah, that's my one view.
But what about nowadays? Well, I mean, if people move from batch to streaming, because Rohit just mentioned that people need to think, right? Well, do they really think about the technology, or they think that they probably need to pay more money?
I think it's actually both cost and just like cognitive overhead of thinking. I think the way you can think about it is like people have like batch pipelines in production, and they can prototype streaming pipelines in like a notebook. But like what gives them confidence to move it to production? So they need confidence that they will be able to monitor these jobs, and they have confidence that they will be able to run these. So often for that, they actually will need to understand the concepts today. And then the next thing is like cost, basically. So for example, like if I'm running this in production, like what is my expected cost? So I feel like a lot of times we see people with batch are able to prototype with streaming and able to get something going. But then there is a like step function after that, which is how do you feel confident moving this to like a core production workflow in your company? And at that at that point, basically like cost, cognitive overhead of thinking of all these concepts, like everything comes into like picture. And so in those concepts, like using a vendor or a data infrastructure provider can help you with some of these things because they come out of the box for you essentially.
I just maybe want to caveat that with the real-time machine learning will definitely yields a lot of value to people, but it does, for example, require more sophisticated data infrastructure underneath. So, for example, companies, if you want to do very real-time ML, you better have some streaming transport infrastructure, Kinesis, Kafka, and into which you're pushing your events. Because if you ultimately push your events into Snowflake at a 1 hour cadence, even if you have like a streaming platform in front of it, the features are not going to be very, very fresh. And similarly, you need to have some model serving infrastructure that's going to be able to use those fresh features and do model inference in real time. So it does require more sophistication from the buyers, where they are able to like stitch together these systems. Vendors like Fennel can make that easy. But that additional work and lift is required. But once people get there, it's a complete mindset shift. I think as Rohit was mentioning, and it's very hard to go back.
I guess maybe from my perspective, I think it's like there are three things people care about with data computations, right? It's just like one is correctness, and the other is latency, and the third one is cost. So I do think it's like the batch wall is like it's cheap and correct, right? You just run the batch jobs, the result is pretty correct. But when you want to achieve the latency and you want to achieve like faster speed, then you have to sacrifice something, right? Like if you want to compute data like very fast, very correct, then you would have to have a lot of like memory bandwidth usage, and it's pretty costly, right? Or if you want to like, if you want to sacrifice a little bit on the accuracy, on the correctness or computation, and maybe skip some of the data, then you can have faster speed and like cheap, but it's not quite correct. So I do think like figure out. I do not believe that there's like a magical solution that's like cheap, correct, and also super fast. Maybe we have there like in 5 years, but not today. So I do think it's important to provide a way for like users to easily make trade-off, right? Because maybe sometimes you're okay with things being a little bit slow, but like very correct. But sometimes like things are moving so fast, I need it to be very fast, and I'm okay with being like 80% accurate. Yeah.
Yeah, I totally agree. We are based on our experience. So what we found is that people were, I mean, when we talk to people about the stream processing, I mean, people were thinking about a lot about I mean, like checkpoint, Java ecosystem, yeah, a lot of watermark, right? So all these kind of concepts, and they probably do not really have chance to talk about cost, and they just too scared about introducing too many new concepts. And regarding cost, well, I think what we observe that, well, I mean, if you care about, well, if you do not really care about the freshness, like okay, you can just use some I mean Snowflake and to trigger the query, I mean every single hour, or probably every few hours, 6 hours, then definitely, I mean, if you translate to stream processing, then I think there's definitely a cost increase, right? But if it's I mean, it's if your user pattern is more like okay, every 5 minutes I just trigger the query, then I think actually stream processing can be even cheaper, because well, it's incremental computation, it's not full computation. So yeah, that's what we observed. In terms of correctness, well, definitely that's something. The other one thing we observed is that people actually care a lot about the consistency and exactly once, and also fault tolerance, right? Well, what will happen if the system crashes, right? And what we found is that when people write, I mean, if they use existing, I mean, like Flink, Samza, Storm, those kind of systems, they actually need to care a lot about the technical details, right? So they are not quite confident, because we expose a lot of details, so they are actually not quite confident about okay, whether my program is correct or not. So I think that's why there are some concerns about the correctness, right? Because I mean, look, I mean, if your program is correct, then I think most likely, I mean, if you use mature system that is mature enough, then you should see correct results. But people are not quite confident when writing programs, streaming programs nowadays. Yeah, but well, I think I mean, that's something that's okay. Definitely the next generation systems within, I mean, right, we'll need to address, right? Yeah.
Should we address these two questions? So the first one is, could the panelists shed some light on which programming language the real-time machine learning frameworks are mostly evolving in the current landscape? I don't know. Does this have to do with Elon Musk's recent tweet?
No, well,
yeah, maybe.
What's the recent tweet?
So Elon Musk recently replied that the AGI is going to be built in Rust. I mean, I don't know what was like, somebody said like Python, he replied just Rust. So I'm not sure if this is the reference to that tweet, but go ahead, please.
Yeah.
Did you see maybe when you're quoting famous people, when did you see Andre Tapati tweet about like English is a new hottest programming language. So I think everything's gonna be like just like AGI English.
Well, yeah, I think that's from the that's from the user interface perspective, right? Well, I mean, I think well definitely, I mean, English is definitely, I mean, a natural language, right? Well, no matter what kind of language you speak, right? Well, can be Hindu, right? Well, can be English, can be French, can be Chinese, right? Well, no matter what kind of language it could be a query language, right? And from the data infra, I think, well, I mean, we use Rust not because well, so many people are using Rust, but because well, Rust are fast and secure. I think that's definitely a key thing we want to, because well, if you use C++, is also fast, but the problem here is that okay, it's yeah, it's much easier to run into some issues, right? For like SIG11, right? So if you run into those bugs, then it will take a huge time to solve the problem, right? That's what we can observe.
Yeah, I can add that like most people would like to write code in just like pure Python and then have it executed in like whatever is the most efficient way that the system wants to run it. And so I think earlier we saw systems like Spark and Flink, and they had to build like PySpark, PyFlink, and we are now increasingly seeing systems that are like essentially built on Rust, and then they allow people to write Python code which gets compiled into Rust essentially. And so, but I think as far as like developers are concerned who are like building on top of like they're building streaming applications. Most likely, I think they would, at least we see a lot of like Python being like the core essentially development workflow.
Okay. And somebody who is obviously want to transition to machine learning is asking, does having a strong knowledge of math and statistic is critical?
I just want to say I have a hard stop now, so I actually have to leave. But it's been a really wonderful discussion. Thank you so much, everyone.
Thank you so much, Chips. Yeah,
Sure.
if anyone can stay just like a few more minutes. Zhang Zhang from Claypot is saying hello. You can connect with him on LinkedIn if you want to further discuss the topic.
Yeah, regarding the math and statistics, well, I'm not sure whether Rohit and hey, do you have any idea about that? Well, I think for nowadays, well, people do not really need to learn a lot about the math and the stats, right? But definitely, I mean, if you have the background, then yeah, it'd be great, right?
Right. I think more than training your models, for example, like you need some background in statistics, maybe to analyze the results and be able to know when what the model is throwing at you is making sense versus not making sense. And having that insight, you don't need to have very deep statistics background, but if you are able to make sense of that, I think that's generally good enough. Obviously nowadays we have more specialized data science courses which teach people how to do that, and you don't have to do like very deep math degree to be able to do that.
Yeah, I would also have like a lot of like stream applications are doing like aggregations, etc. And so a lot of like frameworks provide like built-in aggregation types. So if you want to implement a percentile, you can declaratively say, I want a percentile on this column instead of like writing the code to compute the percentile.
Thanks. I think we addressed all the questions. So it was a pleasure having you all. Thank you for your insight. Thank you for this discussion. Thank you everyone who joined us today. We'll be sending the recordings, and yeah, we hope you had fun today. Bye everyone.
Thanks, Joanna, for hosting.
Thank you. Bye-bye.
Thanks. Bye.